Today we're going to study a charged particle in magnetic field. Let's see, for example, we have some particle, positive particle. Let's see, the particle is moving to the left like that. And this, let's see, is positive. And it's moving with certain velocity v. And let's see, for example, the magnetic field. The magnetic field it's moving in some magnetic field that's coming out of the page. So I put here a dot. This is the head of the arrow coming at you. Okay. So we need to use the equation F is equal to Q V cross B. Okay, we use this equation, and we can apply this equation to the right-hand rule. So let's see. We have the velocities going to the left, so I use my right hand. See, it's going to the left, and the B field is coming out. So my thumb is going up. This is a proton. So the force, look, see my thumb, look, my hand is following the velocity. My fingers going with the velocity, and the B field is going up. So my fingers need to rotate, to turn like this. And if you look at my thumb is going up, so the force is going up. Here is the force. So what's gonna happen? The particle is gonna veer like that. It will veer. Now, if we have, let's see if we have magnetic field all over here. We have the magnetic field all over here. Here, all over the place. This particle will actually rotate like that, move around like that. It will move. It will make a circle, because you see, at this point the velocity is going this way. Now the force is gonna act this way. At that point, the velocity going up, the force will act this way here. So you always have this force try to go towards the center, you see, and it's kind of pushing it, making it go around in a circle. So this force here is the magnetic force. Now we apply Newton's law, Newton's second law. Ma is equal to the sum of forces. Okay, I put here from 1 to n, and then I put I. Now we have only one force, this magnetic force, so I can put here Q V cross B, and this is the force. Now we can see here the magnetic field is going up and the velocity is going to the left, so they're perpendicular. So this will be just QVB. Now, if they were not perpendicular, we will have different situation. We will have Q, V, B, sine. This is the angle between V and B. If, for example, V was going this way, and B was going this way, and this is V, then the angle between them will be theta, which is this one, so the force will be equal to QVB sine theta, and the angle will be this. But since here in this situation F and the B field and the velocity are perpendicular, we don't have this sine pi over 2 is just 1. Now here we write MA is equal to QVB. Now since we have a circular motion, the acceleration here is a normal acceleration, which is v squared over r. So we'll write down here m v squared over r is equal to qvb. Cancel v, and then we have mv over r is equal to qb. Now you can actually use this equation V is equal to R QB over M. And this will be the velocity of this particle going around. It depends on the B field and depends on the radius. If the radius is big, the velocity will be big. Magnetic field is big, the velocity will be big. These Q and M are fixed, don't change. Now, you can actually calculate the frequency. You can calculate the frequency of how many cycles per second is gonna go. So what you do for that, we use this equation. Vt is equal to 2 pi r. Okay, now if you take some line or some wire, okay, and then we have some bead here. This bead is going with certain velocity v with no friction, and this distance here is x. Since the velocity is going constant, we don't have any force. Let me put here, we don't have any force, so the velocity will be constant. We don't have any force in the x direction in this situation, so I can write x is equal to v times t. Now if I take this wire, this is the wire, so if I take this wire and bend it into a circle like that, this will still be x, but this will be r, and then I have x is equal to 2 pi r. Now this x is the circumference, which is 2 pi r, but since x is equal to vt, now I have 2 pi r is equal to vt. Now this t here is the time to make one cycle, so we just call it a period. So I put here v times period. So this t here, this t is the period. Now I have this formula, which is this one. See that formula there. Now v is equal to 2 pi r over t, but 1 over t is the frequency, so this is 2 pi r times the frequency. Now this v here is equal to that v. They're equal to each other, so I just use this. I put here v, or this v, r qb over m, and is equal to 2 pi r f. This equal to that, and we can cancel r, and we have qb over m is equal to 2 pi f. Now f is equal to qb over 2 pi m, and here is the frequency.